Students, in our previous session we have seen one shortcut technique in derivatives for the logarithmic differentiation. Now as I said, not always the shortcut techniques are available, but whenever they are available you make sure that you should be using them to solve the questions. So students, I welcome you all to this channel Pankaj Lade. Today we are going to see one more technique for solving some questions in derivatives. Now if you remember, there is one section in derivatives called as implicit functions. Implicit functions. Now I hope you already know what implicit functions are. For instance, if I write ax square plus 2hxy plus by square equal to 0. So if you remember that this is an implicit function of the variables x and y. Y is a function of x, but y is itself involved inside the equation, and it is sometimes very difficult to isolate y as a function of x. I'll give you one more example. For instance, if I write y raised to x plus x raised to y is equal to some constant c. So in such kind of cases, we already know that y is a function of x. Y is some function of x, but y is also involved inside the equation itself, and the isolation of y in terms of x is slightly difficult. So such kind of functions are called as implicit functions, and if I want to get the derivatives of implicit function, we have some conventional way of getting the derivative. Make sure that you also know the conventional way. For that you need to watch my previous video on implicit functions and the derivatives. So students, I am going to discuss with you a shortcut technique for finding derivatives of such kind of functions. So let's try and understand. I am going to differentiate these two functions only to get the concept of implicit functions. What is the shortcut technique? Now, for such kind of functions, if I want to get dy by dx, learn this and learn this well. If I want to get dy by dx, I'm going to write a formula, memorize a formula, and also understand what the terms are involved and what they mean. So dy by dx is given by, there is going to be a negative sign. Remember, so there is going to be a negative sign at the beginning. So minus sign. And then this is called dou f by dou x and dou f by dou y. Now your head might be going bonkers. What is dou f by dou x and dou f by dou y? What is f here, isn't it? So let us not worry about these things at this moment. Let us try and understand the terminologies very properly. Now here the first thing that you want to understand or you want to know is what is this dou. Sometimes it is called as dou, sometimes it is called as daba. So dou f by dou x or daba f by daba x. My convention or my convenience is when I spell it out as dou. So I will always be spelling it out as dou f by dou x. So what is dou f by dou x? It simply means you differentiate f. Differentiate f. Do not worry students at this moment what is f. I am going to come to that what f is in a short moment from now. Just understand what is dou f by dou x at this moment. So differentiate f with respect to x, keeping y as a constant. This is what dou f by dou x means. Actually in engineering, when you go to engineering, you are going to get this dou f by dou x in your semester 2. Most of the universities will have dou f by dou x in semester 2. What is dou f by dou x? It is called partial derivative. So I'm not going to go into too much detail of what partial derivative is, because at this moment we have to just understand the technique. So dou f by dou x means you differentiate f. I don't know what is f at this moment, so I should not be worried because I'm going to get my answer. So dou f by dou x means differentiate f with respect to x, keeping y as a constant. Likewise, When I say dou f by dou I, what do I mean by this? So dou f by dou I is differentiate f with respect to y keeping x as a constant. Keeping x as a constant. So let's try and understand in the example over here. Now for this again I need to know what is f. So students, whenever any equation is given to us, you always write that equation in this format: f of x comma y equal to 0. Take all terms of x, all terms of y together on the left side. Every term of x, every term of y, whatever is present, you take all the terms along with the constant, everything on the left, and keep right hand side empty. Keep 0 over there. So here it is already in that format. All terms of x and y are on the left and the right is 0. If I want to arrange this is y raised to x plus x raised to y equal to c. I can write this as y raised to x plus x raised to y minus c equal to 0. So now this is of the format f of x comma y equal to 0. So have you got your answer? What is f here? So f is nothing but a function of x and y entirely kept on the left hand side, and the right hand side is 0. Right hand side always and always has to be maintained 0. Now if I come to the differentiation dy by dx, let's see how do I get dy by dx. I'm going to take the example, the first one. I'm going to get the answer for the first one here. So see how in one step itself you can get the answer. So the dy by dx becomes equal to minus of, what is it telling? Differentiate this f with respect to x, keeping y as a constant. So you train your mind to see y like a constant. Y is a constant for me. And what is a derivative of a constant? The derivative of a constant is 0. And if the constant is accompanied with a variable x, the constant goes outside the derivative. So I'm not going to go into too much detail of derivatives. You already know how to differentiate the things. I'm just going to write the answer. See how quickly I can get my answer. So I can write here, so differentiate this f with respect to x, keeping y constant. So what's the first term you see? Ax square. What is the derivative? 2ax. A is constant. Derivative of x square is 2x. What's the next term? 2hxy. 2 is constant, h is constant, and you know that y is also treated as a constant. So plus 2hy, everything is constant, and the derivative of x is 1. And when you go to the last term, by square, b is constant, and you now know in your mind that y is also treated as a constant. So by square is entirely a constant. So the answer is going to be 0, isn't it? So that's my answer only of the numerator, differentiating f with respect to x, keeping y as a constant. I am going to repeat the exact same thing for the denominator now. In the denominator again I am going to differentiate, but this time I am going to treat x as a constant and I am going to differentiate with respect to y. So let's differentiate with respect to y. It is as simple as differentiating with respect to x. If I ask you the derivative of x square with respect to x, your answer comes 2x. So if I now ask you to differentiate y square with respect to y, your answer should be only 2y. It is same as differentiating term of x with respect to x. So you're differentiating term of y with respect to y. So when you come here and you start differentiating the same f with respect to y, you are going to treat x as a constant. So what's the first term here? Ax square. A is constant, and now you know in your mind that x is also treated as a constant. So ax square is entirely a constant. Its derivative is 0. Then plus 2 is constant, h is constant, and now you know that x is also constant. So 2hx is all a constant. And what is going to be the derivative of y? It is like x only. The derivative of x is 1. So the derivative of y is also going to be 1 when differentiated with respect to y. And then finally plus by square. So b is constant, and the derivative of y square same as x square. If it is 2x, y square derivative will be 2y. So I'll write here 2y. If you observe from the numerator, you can take out 2 common, and from the denominator also 2 can be taken out common. So the 2 in the numerator, 2 in the denominator will get cancelled, and your answer simply comes minus of ax plus hy upon hx plus by. So did you observe? I have again got my answer in just one step. That is how the techniques, the shortcut techniques can be powerful. But as I said, not always. Do not use these techniques in your board exams. You keep it aside only and only for your competitive exams, because there nobody is expecting from you to write the entire solution. You just have to come at the right answer. You have to arrive at the correct answer. So in any ways you want, you can come to the correct answer. So at that time using shortcut techniques makes sense, but do not make use of them in your board exams. Let us take the example y raised to x plus x raised to y minus c equal to 0. So here also, now if I want to get dy by dx, see how you can get the answer in just one step. So I am going to write dy by dx is equal to, I write a minus sign, the formula tells me to write a minus sign, and then dou f by dou x, that means I am going to differentiate this with respect to x. Now when I say differentiate f with respect to x, I am going to treat y as what? Y is going to be a constant. So come here, y is a constant, isn't it? So you treat it like a constant. You can read it as a raised to x. What is derivative of a raised to x? It is a raised to x log a. So a, which is y, raised to x into log a, which is y. So log y, and then go ahead plus, as I said, y is a constant, so x raised to y is a constant, you can read it as n, x raised to n. So what is derivative of x raised to n? N, which is y here, into x raised to n minus 1. So x raised to y minus 1, and then the derivative of constant is going to be 0. See, every single term which is present here is f. Every single term is going to get differentiated. That was a numerator. Come to the denominator now. In the denominator, I am going to differentiate with respect to y, keeping x as a constant. So differentiate with respect to y, keeping x as constant. So x is constant for me. X is constant for me. You read it as y raised to n. So what is the derivative of y raised to n? N, y raised to n minus 1. So x, y raised to x minus 1, and then plus x raised to y. You are differentiating with respect to y, keeping x as a constant. So x is constant for me. So you read x as a. So a raised to y is variable like a raised to x. Derivative of a raised to x log a. So derivative of x raised to y, x raised to y. Remember, x is a constant. So a raised to x, it is of form a raised to x. Derivative of a raised to x log a. Understand the terminology. Don't get confused between x, y, this, that. Variable and constant is what you have to understand properly. X is a constant and y is a variable. Y is a variable, so it is like a raised to x, and derivative of a raised to x is a raised to x log a. That is what I am using here. So x raised to y log x, isn't it? X raised to y, x is a constant, x raised to y log x. So from here, now if you want, you can simplify it a little bit. You can write y raised to x minus 1 as y raised to x upon y, x raised to y minus 1 as x raised to y upon x, and you can simplify as the answer is. Whatever options are given to you, you can modify whatever answer you have got. But have you again realized you have got the answer in just one step? So students, this is how implicit functions can be differentiated in just one step. The formula, you remember the formula, dy by dx is equal to minus dou f by dou x upon dou f by dou y. What do you mean by dou f by dou x? You differentiate f with respect to x, keeping y as a constant, and when you say dou f by dou y, you differentiate f with respect to y, keeping x as a constant, isn't it? And what is f? You collect all terms of x and y in the equation on the left side along with the constants, along with any of the other terms, and keep the right hand side empty. Only 0 must be present on the right hand side. So whatever things are collected on the left is called as f. So these 3 points must always be remembered when you are solving questions on implicit function. I hope you have understood what this technique is. Make sure that whenever you get a question on implicit function, you make use of this technique to solve your JEE questions. So students, I thank you all for watching this video. You all have a great day ahead.